In this video, we are going to try to understand the derivative of a function. Actually, we are going to try to understand the relation between the limit and the derivative. What is the relation between the limit? Because the first chapter that we learned, it was the limit, and after the limit subject, we learned the derivative. And this topic, limit h tends to 0 fx plus h minus fx over h, this is here with the sign also, this apostrophe we have here, f, this sign shows us this is the derivative of the fx, this is the derivative of fx, it's going to be, and this sign, when you see this sign, it is not like 1 as you see here, it's not 1, only dash sign, and that sign shows us the function's derivative. Okay, how to find the derivative? And for the derivative, we have this formula: f derivative x is equal to limit h tends to 0 fx plus h minus fx over h, it's going to be. And if I replace in this function here, limit h tends to h tends to 0, x square, it's going to be fx is equal to x square, so fx plus fx is equal to x squared is going to be. What about fx plus h? Fx plus h, it's going to be equal to, instead of when you have x plus h instead of x, you have to write in the function also x plus h instead of x. So it's going to be equal to x plus h square minus fx is equal to x squared over h, it's going to be. And this is equal to limit h tends to 0 x square plus x squared plus 2 times x times h, which is a plus b squared, plus h squared minus x squared over h, it's going to be x squared, and this minus x squared. When you simplify, the expression becomes h limit h tends to 0 2xh plus h squared over h, it must be. And this is the limit h tends to 0, h parenthesis, if we get 2x plus h over h, because when you replace this h by 0, you are going to understand that this is 2 times 0 plus 0 square, which is equal to 0 over 0, indeterminate form. I have to factorize h parenthesis, when you get your left here, that one, and limit x tends to, limit h tends to 0, 2x plus h is equal to 2 times x plus 0, which is equal to 2x, it's continuing. So f derivative x, it's going to be equal to 2x if fx is equal to x squared. Okay, if we solve another function, find the derivative of the function fx at x is equal to 1. Here, this is f derivative a, and f derivative a, limit x tends to a fx minus fa over x minus a. But there is another method, because we have found this one before, this kind of find the derivative of the function. We found this by using this method. At the same time, we will find first the f derivative a. We will find first the f derivative, then we will find the f derivative a also. And we will check by using this formula. Okay, let me find first the x is equal to a. It's going to be, so a is equal to 1 for this question. So this is limit x tends to a. Instead of a, I am going to write 1 in fx minus f1 over x minus 1, and that's going to be equal to limit x tends to 1 x squared minus 8x plus 9, and f1 is equal to fx is equal to, you know, x squared minus 8x plus 9, but f1 is equal to 1 squared minus 8 times 1 plus 9. f1 is equal to 1 minus 8 plus 9, which is equal to f1 is equal to 2 is going to be. So the expression will become like this. This is fx minus f1 is equal to 2 over x minus 1, which is equal to limit x tends to 1 x squared minus 8x minus 7 plus 7, over x minus 1. I have to factorize because when I replace this one, 1 squared minus 8 times 1 squared minus 8 times 1 plus 7 over 1 minus 1. This is up 0, down 0, 0 over 0 indeterminate form. So I have to factorize this one, and it's going to be equal to limit x tends to 1 x squared minus 8x plus 7. You can factorize x and minus 7 minus 1. The sum is equal to minus 8, so this factorization is true. Minus 8 times x minus 1 over x minus 1, and it's equal to limit x tends to 1. When you simplify this to x minus 8, it's going to be, x minus 7. And this is going to be equal to x minus 7, it's going to be, so when you replace by, it's going to be equal to 1 minus 7, which is equal to minus 6, and f derivative a, which is equal to f derivative a is equal to f derivative 1 is equal to minus 6 is going to be, okay, if it is related with the limit, the derivative, then in some conditions we are not going to find the derivative, because in some conditions the function is not limited. We cannot take the limit of the function, in which conditions we learn in discontinuity. Here we are going to add two statements also here. One of them is corner point. If there is a corner point, we can draw infinitely many lines. That's why at this point we cannot find the tangent. And we have vertical tangent. If a graph is parallel to y-axis, vertical to x-axis, then we cannot find the tangent line at that point, so we don't have the derivative for these values. Here on the example, for which values we have the derivative, for which values we don't have the derivative, it's written here. And for a, no derivative, x is equal to a, no derivative, because it is discontinuous. X is equal to b, no derivative again, because discontinuous again it's going to be. because this point removable discontinuity. For C, x is equal to C, no derivative. It's going to be, the reason is same, discontinuity. Here D, E and F points are, as you see here, these are the corner points, so x is equal to x is equal to D, x is equal to C, x is equal to E, and x is equal to F. For these points, no derivative. The reason is same for all of them, because it is corner point. For corner points, we don't have the derivative. Corner, this is corner point. Okay, the last one is x is equal to G. X is equal to G, as you see, it's perpendicular to x-axis, so it means that we have vertical tangent. Vertical tangent means tangent is infinity. That's why we don't have derivative, no derivative again for this case. It's going to be